understand what is affecting this phase. So how is this phase and what is affecting this phase? Now if I take for example my quantities, like I have an AC quantity, okay. So in my AC quantity, if this is my voltage, okay, like this, because it's sinusoidal voltage, okay, okay. So this is my voltage graph. uh, Let this be my current. This is my current. Green one is current, red one is voltage, okay. So this is my time. Now you tell me whether this current voltage and current are in phase or not.
They're in
Yeah,
same phase, sir.
they are in
Yes, sir,
same.
in same phase.
They're in same phase. What is the reason that they are in same phase? Tell me. Why you are telling? Although you are seeing the, see here, if I say that this particular point here, this 10, okay, this particular point over here, the maximum point is 5. So you can see that the magnitude of the those quantities are different. Okay, the voltage is having 10 volts magnitude maximum value, wherein the current is having 5 amps. So how can you say that they are in the same phase? What was the
They're,
reason for
they're moving in same direction, no, sir.
they are moving in same direction? So the thing is that you can say that the sinusoidally varying alternating quantity can be represented graphically, so by a straight line with an arrow in the phasor representation method. So how do you say that they're in the same phase? Is that the length of the line basically represents the magnitude of the quantity. So this length represents the magnitude of the quantity, okay, and the arrow indicates its direction. Now this arrow would indicate its direction, okay. uh, and what is important is that this quantity which is varying sinusoidally, which has a magnitude and direction, is called as a phasor quantity. That's why when I'm representing my current, suppose I have time and again I have represented my current I don't write I, but how do I write I? How do I write? If I have to write an AC current, how do I write? In DC current I is I, okay, but in AC I, how do I write?
I know it's sine omega t.
Yeah, very good. So I write, if I have to write I, so I write I is equal to I max sine omega t. Okay. So this I max value is this value. This is my I max over here. Okay. And the direction, this sine omega t is this. So it is varying with respect to this. And this is my t basically. So if I have to find at this instant, I can find the value of I. So that's why so many concepts came. That peak value concept came. Why in DC it is not there, the peak value concept? If somebody asks you in an examination, in DC why you don't take peak value, RMS value, average value, your simple answer is that DC quantity is not a phasor quantity, is not a phasor quantity, okay. It only has magnitude, phase, and it is unidirectional. Okay, DC basically is a unidirectional quantity, so it will always flow from like this. Okay, whereas AC quantity is a time varying quantity and its direction is also getting varied, hence it is having peak value. It will also have RMS value. Okay, this peak value is also called as what? Huh? This peak value is also called as maximum value. Okay, peak value. Some in some questions, if they ask you the max value, so this is the peak. RMS value.
Sir, is
All,
practice same?
yeah. Tell me. It is also, then it is also having average value. Okay. Now, if somebody asks you the instantaneous value, you calculate the instantaneous value. What value is that instantaneous value? Instantaneous value is basically I max sine omega t. So at any instant, if I am asking you t is equal to 0.5, so you will calculate, okay, sir, you are asking. So this is I max sine omega value. If you know that f and all value, you can calculate 2 pi f omega value. You can write there 2 pi f at a time instead of 0.5. You get the value, instantaneous value at 0.5. Suppose I change a different instant, I tell you at 10 seconds you calculate. Here t value will vary for instantaneous value. Yeah, somebody was having doubt. Tell me. Yeah, somebody asked
There
me
is
some.
crust and peak is same.
Huh? Crust value, peak value is same. Crust value, peak value is same. RMS value, effective value. Okay, RMS value, effective value, and what else? True value. These three quantities are same. If somebody is asking you, no, if somebody is asking you what is RMS value, what would be your reply to that? Suppose I'm asking you, yeah, tell me what is RMS value. What you will reply to that? Hmm? So RMS value is based. Yeah, yeah. Tell me.
Vmax into root 2.
No, no. Vmax into root 2. No. Vmax divided by root 2. It is, first of all, the equation is wrong. Now I am asking you the definition of it. What is RMS value? See, if you have a resistor like this, and if you are passing a DC quantity, so because of the DC quantity, some heat would be produced. So this is I square RT. If you are passing an AC quantity through that same resistor of same value, and what amount of heat was produced by DC, the same amount of heat produced by AC through that resistor, that is I square RT, will give you the RMS value. This is the definition of RMS value. You got my point? Don't get
Once again, repeat, sir.
see RMS value definition. If you have to write, okay, suppose if you are having a resistor like this, okay, and through this resistor, if you are passing a quantity, that is your DC quantity, if you are passing through this resistor, so whatever heat you are generating, so there will be heat generated. Heat is generated in the form of loss. So loss happening would be I square R, and for how much time period it is passing, that amount of heat you will generate. So the heat equation would be I square R into time. See, if somebody asks you what is the commercial unit of electricity, what you will tell? Commercial unit of electricity is not watts, it's watt hours. It is basically it is kilowatt hours. So 1 unit is equal to 1 kilowatt hour. So that means 1 kilo. Suppose 3 rupees are charged. That means if you have a heater in your home, okay, or a fan in your home, suppose that rating of that fan is zero point 0.5 kilowatts of a heater. So that means if you are burning this fan for 1 hour, so how much heat will be lost? That is zero point 0.5 kilowatt hour. So this is not 1 unit. If you are burning it for 2 hours, then 0.5 into 2, that would be 1 kilowatt hour. So that means in 2 hours you are consuming 1 unit. So that is the concept of this RMS value. So RMS value would be if you have an resistor and you are passing a current that is sinusoidal in nature, AC current. So what heat gets produced? I square RT heat. That heat would be similar to the steady state current, that is the DC current, that produces this amount of heat. So this amount of value, this type of current is the RMS current. So RMS current basically is not the maximum current of AC. It is not the instantaneous current of AC. It is the RMS current, that is Imax by root 2. So this amount of current will flow. See, now I will tell you one good thing about it. See, DC quantity I square R into T you did. Now in AC you will write I RMS square. Okay, so I RMS square into sine omega T. Okay, you just look at this, you'll understand in a much better way. So if you please notice this, so I'll explain you. Yeah. So here, if you, yeah, pay attention to this, so that all your doubts will get cleared. Yeah. Now, if I have IRMS, how I write IRMS? I max by root 2. Okay. So my IRMS is I max by root 2. Whereas in IDC, my value is always equal to I max, isn't it? Whatever point I'm seeing, my value is equal to the maximum value only. What is the maximum value? Here it is 10. Here also it is 10. Okay, so that means my DC quantity, my value would be always equal to I max square R into T. So in AC, I have to replicate the same quantity. I have to get this equation. So instead of supplying a peak value, average value, I take RMS value. So the heat generated in case of AC would be IRMS square into R into T. Now I know my IRMS value is equal to I max by root 2. If this is my equation 1, this is my equation 2. So substitute this equation 1 in IRMS, substitute equation 1 in 2. So you get I instead of IRMS, you write I max by root 2, okay, whole square, I max by root 2. Yeah, I'll drop this. So yeah, so you get I max by root 2 whole square into R into T. So I max by root 2. Okay, so this becomes your I max square R into T divided by 2. So this quantity what you are getting here is equal to the other quantity, that DC value over there. So this is basically what is meant by this RMS value. Okay, so what is the quantity? Although you are seeing there is a variable of 2, so why this variable of 2 is there? Why it is 2? Tell me. Hmm? Why this is 2? See, I have told you. If you look at the AC circuitry, this is your phase, this is your neutral. Okay. So what happens in an AC circuitry? If you have to encounter the loss, so loss, this point is neutral. Okay. So this is called a go path. Okay. Then this point is called a return path. So return path. So in single phase AC, loss is I square R here, I square R here. So loss in single phase AC is twice I square R. Okay. But in DC it is equal to I square R only. That's why when I was calculating the loss that was there because of the AC, it came out I max square into R into T divided by 2. But in reality it is equal to I max square R into T only, because only if you are considering the go path, not the return path. So that's why the principle of this RMS value and this effective value has come into picture. Have you understood what I am meaning to say? Huh? Yeah, those of you who are not understood, please can you tell me where you are not following it so I can repeat? Hmm? Okay. Now let's move to the concept of the phase. Yeah, Manoj, did you understand? Manoj?
Sir,
Yeah, did you follow it?
yes, sir. Sir,
What about?
excuse me, sir.
Yeah, tell me.
Sir, this is there for IIT one, sir. This concept.
No, this is not there. But are you following?
Yes, sir. Sir, can you please revise the previous
Uh,
concept, sir? I'm not getting what to read, sir.
Previous concept in the next class we will revise. In this
Okay,
class,
sir.
let me I will revise that previous concept in the next class. Let me move ahead. So E is equal to, suppose I write E or I is equal to E max. Okay. So if I have to write E is equal to E max sine omega T. We have, yeah, now I got the board that I wanted. Yes. You people are finding it difficult. Okay, so it is for the first time engineering. So other subjects that you must be finding a little bit difficult might be engineering graphics. So how is graphics? Hmm? Drawing, that is engineering drawing. A window. So a little bit you have to practice. In this case, na, in electrical engineering, it's like mathematics. If you don't practice, you'll find it difficult. Okay. It's not that you just give a lecture and you understand everything. So it takes time. Why this board is not writing? Hmm? Yeah, yeah. No, it started to write some lag. So if I write Emax is equal to, okay, Em sine omega t.
Nothing is visible, sir.
Nothing is visible, huh? Wait.
Yes, sir.
Yeah, yeah. Wait. No problem. Now a window. Now you tell me it is visible. Tell me.
Yes, sir.
Mm,
Yes,
now
sir.
it's now it's visible. Very good. So no problem now. So it's coming a little bit. It takes time to load, but otherwise it's good. Yeah. Okay. So if I write my Emax, Emax would be equal to Em sine omega t plus minus phi. So when I write like this, E is equal to E max plus minus omega t phi, what does it mean? This is a concept of a phase basically. So
AC, sir.
AC, this is AC circuit, concept of a phase, AC circuit, concept of a phase. Okay, we are understanding the concept of phase. What is the concept of phase?
Excuse me, sir.
Yeah, tell me.
Before explaining the topic, please mention the name in the
Yeah,
board, sir.
yeah. No, actually, in the very beginning, I have mentioned the board name. So this was the second slide. This is the same thing. Like before mentioning, also I had mentioned in the very beginning. So now we are changing the board. So every okay, I'll write in every slide. Don't worry about that. So basically, what does this mean is that suppose you are having a circle over here. Okay, so this is my circle that I have drawn. Okay, so I know the total angle would be equal to 360 degrees, and from here to here, suppose this is the variation. Okay, this is the angle that is getting varied. Okay, here. So this angle, how it is getting varied? It is getting varied with respect to time and with respect to the frequency. So this theta was equal to omega into time that I told you. So as the time varies, the angle is getting varied and the omega is getting varied. Okay, so this is basically, now if I take a reference for this like this, I represent this like in this form. hmm, like this. So I have this, yeah, I have this here, pi by 2, and I have this pi, this 2 pi. So this is like how my quantity is getting varied. So if in my x axis, that I have this axis as x and this is my y axis, so this is the reference axis. So if I have to draw the AC current shown at the instant, suppose if I have to draw an AC current at instant A, so at here I see there is no magnitude of it. But if at instant B I have to draw, so there is some time also, because here at A t is equal to 0. At suppose B t is equal to 5 seconds. So I see t is equal to 0, and suppose this is the graph for current, and at t is equal to 0 the value of current is also is equal to 0. But at this point at B there is some value of current. At B point there is some value of current. At A point, this is the condition. At B point t is equal to 5 seconds. Let's suppose I is equal to 5 amperes. Okay, similarly let's say that this point we have as here O, and let this be the maximum value at O. Okay, t, suppose let's suppose this is 10 seconds, and I is equal to 10 amps. This is I max. So you are seeing this is a quantity. Now how this quantity is getting varied, how this is quantity is getting more or less. So if you notice, there is a quantity that is varying. That quantity, how it is getting more or less is the, see here. Here, this point was A, okay, and here this point was B. Now this point was O. So what we see is that uh, this angle here, let's say this is C. So I see angle BAC is equal to theta. Okay, theta. Now if I'm changing this angle over here, carefully you look, I'm changing it to this other point. So let this be M. So let this be some point, some angle more. So let this be phi. So if I have to write now, the angle is getting changed. Angle is now angle BAM. Now this BAM is clearly theta plus phi. Okay, similarly here the angle is getting, so this phi is getting varied. This phi is getting varied. So phi can be anything. Phi at M is equal to, can be anything. So if I write, instead of phi can go from M point to O point also. Phi can also move to this point also. Phi can move to this point also. Here also. 180 also. So the maximum value the phi can attend in, that's why this plus minus phi. Till here theta. So this is basically like this, Em sine theta plus minus phi, wherein you know, wherein theta is equal to omega t. So this is how I am representing. So this phi over here, that is getting varied. This phi, okay, this phi is getting varied. This phi is called as phase. Is called as phase. Any doubts you are having, please raise your hands, and anything you want to ask me, you can clearly ask. Are you getting my point? This is called as phase.
Sir, the theta and phi, once again you tell, sir.
Theta is equal to omega t. In the very beginning, I told you theta is an angle that is got by the multiplication of angular frequency and time. So theta is getting subtended here. That depends upon time and the angular frequency. Angular frequency is the rotation of the circle, and the rotation of the circle in a time period gives you the angle. Theta is equal to omega t. Okay, theta is equal to omega t. Here that omega t I have written is nothing but equal to theta. Here I have written theta is equal to omega t. I can write any which way. Em is equal to sine theta plus minus phi, or theta, instead of theta I can write omega t. Got it?
Then how BAM is equals to theta plus phase, sir?
That is, see, uh, BAM. What is angle BAM? Angle BAM here, if you see this angle BAM, what is this angle BAM? It is, sorry, not BAM, sorry, CAM. Angle CAM. Yeah, you are correct. It has to be angle CAM from here. C, A, and M. C, A, M. CAM would be equal to theta. This angle CAM in orange I will represent. So there comes theta, and here comes phi. So angle CM. Now you got it. Hello?
Yes, sir.
That was a slight mistake, so no problem. This is CAM. Okay. So that angle is equal to sine theta plus so phi. So this is an example, okay, to make you understand. Now you are telling, sir, give this handwritten notes for this. Okay. How can I give an handwritten note for an live thing? You are getting my point. Live thing means something as a teacher which we explain. Can we write in notes these points? You tell me, if you have to teach some practical thing, can it be documented? Can this be documented? This is explanation cannot be documented. Yeah, the notes are there, that are a natural way. That's why there is a role of a teacher in a classroom. Okay, so that he can explain you. These things are not, that's why you have to attend the class and understand from that. It's highly impossible to document these things. So now see, if I write this and this, if I don't teach, can notes be self-explanatory? Can they explain you these points, they cannot explain you. So that is the point, that in the classroom you please pay attention. If you are paying attention in the classroom, now you are very lucky also, you can repeat the lecture as well, because now the recording is available. So at that particular point only, if you want to see, you can go to that point and you can see that, but provided you will put your efforts. If you're not putting your efforts, you're not going to get it. It's not like Divya Shakti will come, some Bhagwan Sri Ram will come, keep a hand on you, and you will understand anything, because this is engineering and you have to put efforts. So if you put efforts, definitely you are going to get. Okay. So this phi is called as phase. Okay. So the important thing over here is that now if I keep the value of phi is equal to 0 degree. So in case of voltage and current in DC, if this is my voltage, okay, and this is my current here, like this, okay, you see there is no phase difference. So the phase, they are in phase. But if I draw my voltage like this, okay, and my current is here like this, so there is a theta, so there is a phase difference between current and voltage. So this theta is called a phase difference. So this 30 degree, there is theta is equal to, suppose this is 30 degree. So when theta is equal to 0 degree, what we say is that there is zero phase. When phase of an alter is zero, it is standard pure sinusoidal quantity, and it will have instantaneous value at t is equal to 0. What would be the instantaneous value at t is equal to 0? So at t is, what would be the instantaneous value? Is I is equal to Im sine omega t plus phase. Okay, so this is the instantaneous value. So omega t, okay, phi, what is the value of phi? Phi value is 0. So instantaneous
0.
value will be, tell me, 0,
0.
because it would be Im sine omega into, instead of t it is 0, instead of phi it is 0. So sine 0 is 0. So this value will be 0. Okay, so this thing you have to keep in mind, and the phasor diagram of this quantity would represent just like an horizontal line, so it does not has any phase. So it is like voltage and current are in phase. Now suppose if I say case 2, that when phase of an or is positive, what does that mean? Means the phase of a quantity is positive. That would mean the quantity, if I am representing, yeah, so yeah, where is it? That's not getting selected. Yeah. So if I say the phase of the quantity is positive, what does that mean? So I will say that this quantity has some value. I is equal to Im, okay, sine omega t plus 30 degrees. So that means the angle that I'm going to subtend over here, this phasor angle of, suppose this is my V, the angle between this and this would be at a positive angle. It would be plus phi. Suppose it is minus negative degree. At that case, this is my reference voltage and the phase is in the downward direction. So I'll say this is minus phi. So in that case, I is equal to Im, what is this? Okay, I is equal to Im sine omega t minus 30 degrees. So this is for the phasor diagram for the negative phase. Now notice that when phase is measured in NT, it is positive. Okay, this thing you have to remember. See, this is the anti-clockwise. See how is our clock is like this: 12, 1, 2, 6, 8, 11. So if you have this direction like this, opposite direction, so this is called anti-clock, and this direction is clockwise. So this direction would be anti-clock, and this direction would be, here it is clockwise. So here if you notice, this direction, okay, this is anti-clockwise. So anti-clockwise phase would be positive. Anti-clockwise phase would be positive. Okay, Now let's go for the clockwise direction. What is the condition for the clockwise direction? So if you have to take clockwise, that is like the clockwise direction like this. So I'll write clockwise direction, phase would be negative. See, clockwise it's going down, so phase is negative. Clockwise, phase is negative. Did you get my point? Hmm? Now there is one particular thing called as phase difference that you understood. The difference between the phase of two alternating quantities is called the phase difference. So what are the two alternating quantities that we are having? Suppose if I ask you what are the alternating quantities that we are having, okay? So in power systems or for AC or DC, what are the two alternating quantities that you are having? One is your voltage and one is your, yeah,
Current.
current. So you have your V is equal to Vm sine, okay, this like this sine omega t, okay, and then you have I is equal to Im sine omega t, okay. But now you tell me one thing. Suppose this is my quantity, okay. Voltage would be as it is, you have seen, okay. So this is my voltage. But what I do is I start my current from this particular point. This orange one is my voltage. This is my voltage. The blue one I write my current. So one thing you notice between voltage and current, there is some angular gap. So this is some phase is there, phase difference, because not they are not starting at the same point. You see voltage is starting at point A, and whereas the current is starting at point B, okay, although they are moving in the same direction. So here if I can write that my in this particular case I can write my voltage and my current, okay. If I write my I is equal to Im, because you see the current is starting after a point of, so let this be phi plus phi, okay, and my voltage is starting at the same point, Vm sine omega t. So what I need is I need a phasor difference between these two quantities. Now the phasor difference between two quantities, how do you represent? So I can clearly see my current is leading voltage. So the current is leading voltage. Current is leading voltage by an angle phi. Okay. So this is called as voltage. This is called as leading phase difference. Leading phase difference. So a circuit, an element that creates this leading phase difference is also called as a capacitor. So that in future you will be understanding in the next classes, coming classes. Now in case it was like this, I was equal to Im sine omega t minus phi. So here you see it is lagging. So this is called as lagging phase difference. And this lagging phase difference is created by an element that is called as an inductor. Okay. So wherein V is equal to Vm sine omega t. Now it can be other which ways also. Suppose you did not ask me till now. Suppose I write my I is equal to Im sine omega t, but my V is equal to Vm sine omega t minus phi. Huh? Yeah? Hello? Yeah, tell me. Yeah, tell me. Yeah. Somebody was telling something. Yeah, tell me. Yeah, Srishti?
Yes, sir.
Yeah, tell me. Anything you want to ask?
No, I didn't tell anything, sir.
Somebody was asking something. Please tell. It should be interactive class. No, yeah, tell. I like Manoj very much. I like these people who are asked Krishna Kant and all that. You should be like, you know what, free with the teacher. Whatever is there in your mind, you have to say. While writing also I can be wrong at times, because there are so many things involved, like hand body eye coordination. Sometimes there is a mismatch, so some writing can be wrong or something. So if you are there, like it's a teaching learning process, tell me anything you're not following or something, so you should not keep your doubts in your mind, so it will remain always there in your mind. Whatever is there, you just let me know, okay? And don't read books, like I'll tell you seriously, don't read this Vk Mehta, okay? I don't know who has put, or BL Thareja type of books. Please avoid these books. So you'll get confused if you're reading these books. Okay. Instead of that, if you want to really read, I have a book, Charles Alexander. I'll forward it to understand this. Charles Alexander Sadigo. One book is there. Another book is by this guy. One more book is by, his name is Sergio Franco. Okay. So these books are there, but if you want to read, I'll give these books also in the drive, no problem. As well as you have the notes also. Some I identified a few notes of mine of old, but there are so many things involved there. So you have to take the only portions that are coming for the entrance. That also I'll forward, but you have to practice. Okay, there's no way out. These are some techniques that I'm telling. So if you see here, clearly it is stating your voltage is lagging current. Okay, voltage is lagging current. Here if you see, V is lagging current, or in other terms we can say our current is leading voltage.
So
Yeah.
what
Yes.
this is happening that sometimes current lead voltage and voltage lead current.
Yeah, nice, nice. Here you saw theta, this I wrote by blue, this was my current.
Yes, sir.
So you see the current is starting at an advanced angle. Current is not starting at A point, current starting at B point. Okay,
Yes, sir.
so that means current is leading. Current is leading means current इससे एक स्टेप आगे है. करंट मतलब वोल्टेज अगर 0 सेकेंड पे स्टार्ट होती है आपकी, करंट आपकी 10 सेकेंड्स पे स्टार्ट होती है. ठीक है, तो उसका
Okay,
मतलब
sir.
करंट एडवांस्ड है. अब मैं दिखाऊंगा ये केस. वो ये बहुत अच्छा सवाल आपने पूछा. दिस इज द थिंग आई वांट इन माय स्टूडेंट्स. Then teacher will not know, na, teacher will not know what is in the mind of. Now you ask me this question, मुझे समझ में आ गया कि आपको कहाँ समझ में नहीं आ रहा है. अब देखो, अब समझाने में मजा आएगा मुझे. ये देखो, ये है. ठीक है, अब मैं क्या बोलता हूँ, ये देखो. अब मैं बोलता हूँ भाई मेरी जो वोल्टेज है, इंस्टेड ऑफ यहाँ, ठीक है, यहाँ से स्टार्ट होती है. ठीक है, हाँ, ये मेरी वोल्टेज स्टार्ट हो गई.
Okay, sir.
ठीक है, मेरी वोल्टेज स्टार्ट होती है. ये पॉइंट है जीरो वाला पॉइंट. ठीक है, यहाँ पर मेरी करंट स्टार्ट होती है. मैं बोलता हूँ अब भाई भाई साहब मेरी यहाँ पर करंट स्टार्ट होती है. अब मैं एक चीज देखूं, मेरी जो वोल्टेज है वो जीरो से, अगर मेरा जीरो पे ओमेगा टी पॉइंट है, मेरी वोल्टेज स्टार्ट कहाँ हुई? अगर ये फेज है यहाँ से, ये सपोज ए रख लो आप, दिस पॉइंट यू कीप बी, दिस पॉइंट यू कीप सी. So where did my voltage start? And between A and B there is a phase phi. So my voltage started at A point, but A point is lagging this B point by phi. So I will write my voltage for this graph, figure 2. How I'll write my voltage for this graph, figure 2? Voltage would be Vm sine, not omega t. Omega t is here. Omega t minus phi. ठीक है ना, माइनस फाइव. और
Okay, sir.
करंट मेरी बराबर आई एम साइन ओमेगा टी पे शुरू हुई. आई इज इक्वल टू आई एम साइन ओमेगा टी. तो इस केस में अगर मैं देखता हूं, मेरी जो वोल्टेज है करंट के पीछे है फाई. करंट के पीछे है फाई. और अच्छा तरीका बोलने का है कि जो मेरी करंट है वोल्टेज के आगे चल रही है फाई, तो करंट लीड कर रही है वोल्टेज को. तो ये भी सेम बात हो गई जो पहला केस था, जो आई इज इक्वल टू आई एम साइन ओमेगा टी प्लस फाइव, वी इज इक्वल टू वी एम साइन ओमेगा टी. तो ये मैंने आपको बोला था, ये एक लीडिंग नेटवर्क है, तो ये भी एक लीडिंग नेटवर्क की है.
Sir,
Yeah.
please explain in English, sir.
Okay, sorry. No, I thought is, yeah. So this is I is equal to Im sin omega t, V is equal to Vm sin omega t minus phi. So as you see this network, I is equal to Im sin omega t plus phi. Similar to this, the same result you will get with the second graph also, because if you see the second graph, it is lagging this point, okay, and your current is a bit lagging. And same thing, now if I have to write this, I is equal to Im sine omega t minus phi, or V is equal to Vm sine omega t. So instead I can write I is equal to Im sine omega t only, okay, and for V I can write V is equal to Vm sine omega t plus phi. So this is a case of leading network. These are the cases. Case 1 for leading network. This is case 2 for leading. This is the case for leading. Okay. Now, as far as this network is concerned, this is for lagging. This is a lagging. Okay. Lagging network. This is case 1 for lagging network. Case 2 for lagging network. So here you see these graphs are same. Now if I want to create one more graph, okay, so please pay attention here. See, now, yeah, now this means I is at Im sine omega t, as it is. I is at Im sine omega t, so I is starting like this. So we have this I is equal to Im sine omega t as it is. Now, but V is starting at a phase of advanced phase of phi. Suppose this point A, so V is starting here. So this is my V, and with the blue I have I. So I is equal to I. So this is my case 1, that was the earlier case. This is my case 2. See here, I is equal to Im sine omega t, but V is equal to Vm. V is what? V is starting after an interval of phi. So that means my current, that means my voltage is leading. Voltage is leading current. If voltage is leading current, what current is doing to voltage? That means current is lagging. Okay. What I say is that we are two friends, Manoj and Prakash. Suppose I say that Prakash is running ahead of me. Okay. So Prakash is running ahead of Manoj. So what Manoj is doing? Manoj is running behind of Prakash. So if voltage is leading current, what happens to the current? Current is lagging. So this is the case of current lagging. So this is the case of a lagging circuit, lagging network, and this is the case of inductor. Okay, this is the case of inductor.
Sir, if
So
current lags, then it is an inductor. If current leads, it is a capacitor, sir.
capacitor, yes. Current. Only important thing is current. Current leads, then it's a capacitor. Okay, capacitor network.
Sir,
And
for
current.
current leading capacitor, I is equals to Im sine omega t plus phi.
uh,
Then for inductor, I is equals to Im.
Current lag means inductor. Yeah.
Then I is equals to Im sine omega t minus phi.
Yeah.
Sir, that figure for current leading, can you show, sir?
Which figure for current leading? Yeah, that figure also. Okay, I can draw that one more figure you want.
Yes, sir.
See,
For current leading and current lagging, once you tell, sir.
yeah. This Im sine omega. See, this is Im sine omega t plus phi. If I am drawing, see here, what I do is same figure I will change. See here, instead of Im sine omega t, what I do is that I keep this as current I. So that means current is leading. So this is phi. Whereas V is equal to this point. So V is equal to Vm sine omega t. So you are seeing the same thing is happening, right? So it's a capacitor network. What my point? Now if I have to this negative network here. So what I write, V is equal to Vm sine omega t minus phi. So V was this and Im was this. So this is the case for the case one. Case one, this orange is there, right? The case one orange, this figure. Okay. Well, right. figure 1. Okay, here I'll write this figure 1. Oh, case 2, if you want to go for case 2, this is blue na, so this is case 2. Okay, this is case 2, figure 2. Okay, take down. Now let's see. Now here case 1, I is equal to Im sin omega t. I is equal to Im sin omega t.
Sir,
In
in
case
both
2,
cases, voltage is lagging, no, sir?
listen to me first. Listen to me first. So this case 1 and case 2 you understood. This thing you understood. Case 1 you understood.
Sir.
Case 1 you, yeah, in this case 1 is the upper case. So these two cases are different cases. This from here there is a second case. Only see on the upper side, this portion you tell me. This portion is for, this particular portion is for leading. Okay, so this particular portion is for leading. So here if you see voltage is lagging. Voltage is lagging means current is leading. Voltage is behind. Okay, Manoj is behind Prakash means Prakash is ahead. You got my point? Or Prakash is ahead means Manoj is behind. Prakash, see, if I have to calculate this angle, only angle if I have to calculate, if I do this sine omega t and this omega t, so what I'll get, omega t cancels, I'll get a phi angle. Here also I get a phi angle. So the distance between them is phi. Got my point?
Yes, sir.
Hello? Yeah. Similarly, if you are looking here, this is for the lagging case. Now you please put attention. 10-15 minutes break I'll give to you people. Then we have one more class. Then I'll come back after some time. So you, for lagging case, you please identify the diagram how you are going to create, like on this basis only. So put some pen to ink to paper, and I'll come in some time. So I'll stop recording for now, and take some 10-15 minutes break, and then we'll go for the next class and I'll explain you. Any doubts you are having?